Hi all, I'm Pragya Srivastava, an educator on Unacademy. Follow me on Unacademy Learning app where you'll find my many more courses specially designed for GATE aspirants. And kindly rate, review and share my lecture, and your reviews means a lot to me. And in this lesson, we'll be studying about plate load test. Plate load test is a field test to determine the ultimate bearing capacity of soil and the probable settlement under a given loading. The test essentially consists of loading a rigid plate at the foundation level and now determine settlements corresponding to each load increased. The ultimate bearing capacity is taken as the load at which the plate starts sinking at a rapid rate. On a log-log plot between load intensity Q and settlement, the QUP, the applied pressure, is indicated by a break. If the break is not well defined, in that case, the ultimate load is taken as that corresponding to a settlement of 1/5 of the plate width. On a natural plot of load settlement, the ultimate load is obtained from intersection of the tangents drawn. Let's see what does it says. This is your load settlement curve. I have plotted the points, the different settlement at the different loads that is actually applied, and we get a curve like this. And the QU, from where we get our QU? What we have done that at this point, draw a tangent here at the curve and a tangent here where you find the curve actually moving down. Just draw the tangents at these 2 points. The point at which the two tangents meet actually gives you the value of QUP, which is actually required. This is the point at which the ultimate load is found. The ultimate bearing capacity of proposed foundation QUF is given by, for clay soil, QUF is actually same as QUP, but for sandy soil, QUF is actually equal to QUP multiplied by BF upon BP. What is BF and BP? BF is the foundation width of proposed foundation, and this BP is your plate width. The relationship between the settlement of plate SP and that of the foundation SF for the same load intensity can be given by these relations. For clay soil, SF is actually equal to SP multiplied by BF upon BP, and for sandy soil, you have SF is equal to SP multiplied by, you can see here, this is BF multiplied by BP plus 0.3 upon BP multiplied by BF plus 0.3 whole square. So this is your formula for sandy soil. This is your settlement of your foundation. Now there are a lot of limitations of this plate load test as well. The first one is your size effect. Size effect means that the results of test reflects strength and settlement characteristics of the soil within the pressure bulb. So it doesn't truly represent the actual conditions if the soil is not homogeneous and isotropic to a sufficient depth. Now, there is scale effect. Scale effect means the ultimate bearing capacity of saturated clays is independent of the size of the plate, but for cohesionless soil, it increases with size of the plate, and this increase is actually not taken care of in plate load test. Now, it has time effect. Time effect means what? This test is essentially a test of short duration. So, for clay soil, the load settlement curve is not truly representative. Why? Because clay soil actually takes somewhat longer time for its settlement, for its ultimate settlement. So, the load settlement curve is not truly representative of the settlement that actually happens in a clay soil. Now, there is one more. It says that interpretation of failure load. The failure load is not well defined except in case of general shear failure. And for other types of failure, the error is actually mere interpretation. So, there are chances of error actually arises. Then we have a reaction load. Reaction load, it is not practicable to provide a reaction of more than 250 kilonewton. Hence, the test on a plate of size larger than 0.6 meter width is actually difficult. Then the error may arise because of this water table. The level of water table affects the bearing capacity of sandy soil. So, if water table is above the level of the footing, it has to be lowered by pumping before placing the plate. The test should be performed at the water table level if it is within about 1 meter below the footing. I've seen a question which actually appeared from this portion in GATE 2017. It says that the plate load test was conducted on a clay strata by using a plate of 0.3 meter cross 0.3 meter dimension, and the ultimate load per unit area of the plates was found to be 180 kPa. The allowable bearing capacity in kPa of a 2 meter wide square footing would be. 4 options are given to you: 27, 180, 1200 and 2000. Let's see the question once more. What is given? What is asked? A plate size of plate load test is known to us, 0.3 cross 0.3, and the ultimate load per unit area of the plates was found to be 180 kPa. This one is given to us, and you need to find out the ultimate bearing capacity on a 2 meter wide square footing. The width of the footing is given to you, and ultimate bearing capacity needs to be found out. Can you guess what can be your answer? In a plate load test, the ultimate bearing capacity does not depend upon the width of footing. So, We have already studied that actually QUF is equal to QUP, and QUP is given to be 180 kPa, hence your answer is going to be 180 kPa. A real tricky question because nothing needs to be done here, no calculation work is needed, just you need to remind whatever we have learned. Go through this, the questions are very direct, you just need to remember the basic things and tell me, you keep studying.